Good morning, students. I am Professor Arti Prasad, Department of Electrical and Electronics Engineering, SIRT College, Bhopal. Today we will discuss the digital electronics logic design, and the subject code is EX403. Right. So today we will discuss the topic of adder. The topic is adder, and in this session we will discuss the what is adder and the types of adder. Right. So what is adder? Adder, adder is a digital circuit that performs addition of numbers. In many computer or other kind of processor, adder are used in the arithmetic logic units or ALU. So they are also used in other parts of the processor, which they are used to calculate address, table indexes, increment, decrement, operators, and similar operations, right? So although adder can be constructed for many numbers, representation such as binary coded decimal or a XS3 code, the most common address operate on binary numbers. Okay? So in case where two's complement is being used to represent negative number, it is trivial to modify an adder into the adder's subtractor, right? So other sign number represent require more logic around the basic adder, right? So this is the adder introduction, and adder is two types of adders, a half adder and the full adder. Half adder is a combinational circuit which perform the addition of two binary numbers a and b. A and b are the variable you may take x or y, right, are of single bit, and these two variables are of single bit, not more than single bit. It produces two output, sum, which is assigned by the s, and the carry, that is c. And the second part is the full adder. Full adder is a combinational circuit which perform the addition of three bits number a, b, and c in. C in means carry input. So where a and b are the two parallel significant bits, and Cn is the carry bit, which is generated from the previous stage. This full adder also produces two output sum, S and carry, that is carry output, which is similar to the half adder. So this two types are adder are there, half adder and the full adder, right? So in this half adder and the full adder, the term used is combinational circuit. So what is a combinational circuit and what is the block diagram of the combinational circuit? Let me discuss. This is the diagram of the combinational circuit. What is combinational circuit, right? So logic circuit for a digital system may be combinational or a sequential, right? So combinational circuit consists of logic gates whose outputs at any time are determined from the present uh, combinations of the inputs only, right? It depends on the present combination, not the previous combination, right? So combinational circuit, this is the block diagram of the combinational circuit, right? So here is the n inputs line and the m output line. If number of input variable is equal to the n inputs, so there are the 2 power n possible combination of the input variable. And if m is the number of output variable, then there are m Boolean functions corresponding to each output. So this is the some introduction of the combinational circuit. Next we move to the our topic is adder. So half adder is a combinational circuit. Combinational circuit, as already told you what is combinational circuit. So which perform the addition of two binary numbers a and b are of single bit, and it produces two input sum and carry, right? So in this half diagram we will discuss the truth table. So half adder discuss with the truth table, right? So in this input and output, this is the truth tables over there, and the input, there is two combinations or a two variable. Two variable means you take two variable and two variables means if you take A and B, there is two variables and the combination is 2 power n, right? So 2 power n is equal to, you take two variables, then 2 power 2. So that means here it is 4, right? So in this truth table, 4 combinations are there, right? So you take two variables, so A and B, so you have take 4 variables, right? And then output is the C and S, right? C means carry and the S means sum. When we take A is 0 and B is 0. 0 means low and 1 means high. So you take a 0 or 1 or high and low. Okay? When we take A and B, both are 0 or a low, then we give this carry is the 0 and sum is also 0. When you take the both input, 1 is 0 and B is 1, then we get the C is 0, that is carry is 0 and sum is the 1, right? When input variable is 1 and B is 0, so carry is 0 and sum is 1. And when we take both input are 1 or a high, then we give the C is 1 and sum is 0. That means ki both input, when both input are high, then the sum is 2. That is significantly 1 0. So this is the truth table of the half adder, right? So half adder add two single bit binary number A and B, and it has two outputs, sum and carry, as already discussed in previous PPT. So carry signal represent overflow into the next digits of a multi-digit addition. So the value of the sum is 2C plus C, right? The simplest half adder design picture on the right incorporate an XOR gate for S, that is sum, and AND gate for a C, that is carry. So the Boolean logic for this sum will be A bar B plus AB bar, right? So this is the combination for, or this is equation is for XOR gate, where for the carry we will the AB. So here in these two gates are required, XOR and the AND gate. With the addition of OR gate to combine their output, two half adder can be combined to make a full adder, right? So half adder, two input splits and generate one carry and sum, which are the two output of a half adder, right? So let sum is the least significant bit and carry, and the most significant bit of the resultant sum. For first three combinations of input, carry is 0 and the value of S will be either 0 or based on the number of ones present at the inputs, right? So from the truth table, we can directly write the Boolean function for each output is S is equal to 0. S is equal to A X or B. This is the symbol of X or, right, students? This is the symbol of X OR gate, right? And the second one is the C, and here this is the dot product means AND gate. So half adder we can use two gates, AND gate and the XOR gate, right? So these two gates we use design the XOR gate or half adder, right? Next we discuss the this is the implementation of half adder, or this is the circuit diagram of half adder. This is the half adder, right? So in this diagram shows two outputs S and C and two inputs are there A and B, XOR gate and the AND gate. So one XOR gate and one OR gate combine and make the circuit diagram of half adder. So this is the diagram of half adder, right? Also, this is the diagram of half adder with two inputs and produces sum and carry, right? Then come to the full adder. What is full adder? Full adder is also a combinational circuit which perform addition of three bits A, B, and C input, where A and B are the two parallel significant bits, and C input is the carry bit, which is generated from the previous stage. This full adder produces two sums as sum, carry, and carry output, which are similar to half adder, right? This is the truth table of the full adder. Here we take three combinations. In half adder, we take the two inputs, and the full adder, we take three variables A, B, and C in. Okay? A, B, and C in. So here is the combination is 2 to the power 3, that is 8. So in this truth table, 8 combinations are there like this, right? So in this diagram, in this truth table, we shows first you take 0, 0, and 0. So we get the carry output is 0 and sum is 0, right? When we take input is 0, again 0, and C input is 1, right? So carry output is 0, but sum is 1. Sum means additions, right? So 0 and 1 that is equal to 1. And here again also 0, 1, and 0. So here output is 1, right? When we take two variables are 1, so we take carry output is 1 and the sum is 0, which means 1, 1 is 1, 0. So that means sum is 0 and 1 carry output is 1. When we take 1, 1, and 1, yani 3 times of 1, then carry output is 1 and the sum is 1. So this is the truth table of the full adder we discuss, right? Or in this next we, so let's S is the least significant bit and the carry out is the most significant bit of the resultant sum. It is easy to fill the values of output for all combinations of input in the truth table. Just count the number of ones present at the input and write equivalent binary number at output. If C input is equal to 0, then full adder truth table is same as that of half adder, right? So in this, we will get the following functions for each output after simplification. So sum is the A XOR B XOR C in, and the C output, that is AB, here is the AND gate, plus A bar A XOR B and whole bracket is same input. So S is equal to 1 when odd number of 1 present at the input. We know XOR gate produces an output which is an odd function, right? So again we discuss, this is the diagram of the full adder when we use two half adder join. Here is the one half adder and second one is the again half adder. Those half adder joined with the one OR gate, right? So we take or we get the circuit diagram of full adder. Okay, thank you so much.